In this tutorial video, we're going to see how to use Boolean logical operators in Java. Now, before we can even discuss what they are in Java, we have to go back to basics, which is mathematics, as I'm sure a lot of you have never seen what a logical operator is in mathematics, unless you did advanced mathematics. So, to start off easy, let's start by explaining what a Boolean is. Well, a Boolean is a binary variable having two possible values called true and false. So, concerning the logical operators in Java and in mathematics, we're going to look at the three main ones that interest us. So, let's start off by the first one, the first logical operator, which is called AND. Now, for each logical operator, you have a set of rules and logic. So each operator has its own set of rules and logic. So for each logical operator you have something that is called a truth table. This is a truth table. Now a truth table is a mathematical table that is going to display a number of conditions, and for each condition it's going to display a result according to the logic and to the rule of that specific operator. So to best represent this, I'm going to use an example that's easy to understand. Let's say you're in a room, and in that room you have two switches, light switches. So light switch A and light switch B. Now keep in mind, 0 here means that the light switch is off, and 1 means that the light switch is on. So keep that in mind. So in this first condition, this first line here, light switch A is off and light switch B is off also. So the lights are off. It seems logical. In the second condition, light switch A is on, light switch B is off, but the lights are still off. Now, as I said, that may not seem logical to you, but as I said, each operator has its own set of rules and logic. So my advice to you would be to learn these tables off by heart. So coming to the third condition here, light switch A is off, but light switch B is on. So it's basically the opposite of the second condition, and the light switch is off. So that seems logical, since it's the opposite condition of this one. And the last condition, light switch A is on and light switch B is on. So the lights are on. So in Java you have the exact same operators. So this is the AND operator. It's the exact same operator, it's just represented with these two symbols in Java. And as you can see, these two tables are identical. The only big difference between the mathematics and the Java language is that Java uses, instead of using zeros and ones, it uses false and true. And that's pretty much true for all programming languages. So as I said, if you look closely, these tables are exactly identical. The zeros have just been replaced by false, and the ones replaced by true. So now we're going to try a little example in Eclipse, just so you can get a better hand of this. So let's go to Eclipse, and let's create two Boolean variables. So A, which we'll say is true, and a Boolean variable B, which is false. Remember, Boolean variables can only take on true or false as a value. So now we're going to type system.out.println. We're going to type a little sentence. A and B. Remember, AA stands for the name of the operator in Java. Is space, and then we're going to ask it to execute this condition A and B, like so. So it's basically going to do the condition that we saw on the table before according to these values. So in our example, sorry, here A is true and B is false. So if we go back to our table quickly, A is true and B is false. So the result should be false. So let's see if that's the case. Let's run this program. Okay. And as you can see, A and B is false. So you can play around a bit with the values here. Let's say that B is true. Let's go back to the table quickly. So we said A is true and B is true, so the result should be true. See if that's the case. Let's run the program, and as you can see, A and B is true. So again, I would advise that you learn these tables off by heart. In the next step, I'm going to show you the Boolean operator OR. So meet me in the next step. So now that we've seen the first Boolean logical operator AND, let's take a look at the logical operator OR, which is right here. So in mathematics, the OR operator has its own, again, its own set of rules and logic. So let's keep using the example of light switches in a room. For this operator, if the light switch A is off and the light switch B is off, then the lights are off. In the second condition, if the light switch A is on but the light switch B is off, then the lights are on. Now again, I really want to emphasize on each logical operator has its own set of rules and logic. So in this case, the light switch is on. The third condition, which is the opposite of the second one, the light switch A is off, but the light switch B is on, so the lights are on. And in our last condition, the light switch A is on, the light switch B is on, so the lights are on. So again, Java has the same operator represented by 2 lines here. Again, both tables are identical. So let's try this table. Let's try this operator out in Eclipse. So let's go back to Eclipse. Again, let's create 2 Boolean variables. Boolean A equals true. Boolean B equals false. Same principle. System.out.println A or B is space, and then we're going to ask it to execute the condition according to these 2 variables. So A or B, like so, semicolon. So in this example, A is true and B is false for the Boolean logical operator OR. So let's go back to our table here. So A is true, as we said, and B is false, so the result should be true. Let's see if that's the case. Let's print this out. Okay, and as you can see, A or B is true. Let's change this a bit just to do a second and last example. Let's give A the value of false. Back to our table. So we said A is false and B is false, so the result should be false. Is that the case? Yes, it is. So in the next step, I'm going to show you the last main logical operator that interests us, which is called exor. Sorry. So meet me in the next. So now we're going to look at the final Boolean logical operator that interests us, which is called exor. XOR, sorry, it's pretty hard to pronounce. So let's go back to our table here, and this is where the logical operator XOR is. So let's continue using our example. Light switch in the first condition, light switch A is off, light switch B is off, so the lights are off. Lights in the second condition, light switch A is on, light switch B is off, the lights are on. Third condition, light switch A is off, light switch B is on, the lights are on. Last condition, light switch A is on, light switch B is on, the lights are off. Again, Java has the same operator, represented by a little hat there. So let's test this out in Eclipse. So let's go to Eclipse. Again, creating two Boolean variables. Boolean A true, Boolean B false. Same principle. Dot out. Dot println. A, the little hat here. B is space. Going to ask it to execute the condition according to these two variables here. So A, little hat, B, semicolon. So A is true, B is false. Let's go to our table. A is true, B is false. So the result should be true. Let's see if that's the case. Okay. And it is. Let's try a different example. Let's give the B the value of true. So A and B are true. A is true, B is true. The result should be false. Go back to Eclipse. Is that the case? And yes, it is. So in this tutorial video, you saw how to use Boolean logical operators in mathematics as well as in Java. So keep following us. Keep following the next couple of videos. All of this will be useful for conditions that we'll see in the next couple of videos.